Hello and welcome back to the third Mechanical Engineering and Metalworking Business Forum. I hope you have had a great break, a nice tasty lunch, and you're full with energy to continue the forum. Now we're gonna head into pitch sessions, new partners, inventions of new technologies and materials and services. Each pitch session participant will have 5 minutes for their presentation, and we'll start out pitch sessions with Mitutoyo Metrology Laboratory, Riga Technical University, and let's welcome Vice President of Mitutoyo Polska, Mr. Jakub Ruszkowski, as well as Head of the Riga Technical University Mitutoyo Laboratory, Mr. Jānis Lungevičs. Welcome. Welcome, gentlemen. The floor is yours.
Hello, everyone.
Thank you very much. Welcome. Jānis, you're on.
So, I'm about to give a quick overview of what Mitutoyo Metrology Laboratory is, and in the end, Jakub will have the final word about the future plans and etc. So, this Mitutoyo Metrology Laboratory was founded in a collaboration with 3 institutions. So, here's an overview of the lab. But basically, yeah, the laboratory was opened in 29th of September in 2018. And the biggest key player in this was the Mitutoyo Poland. That's why the Jakub is also participating here, because the Mitutoyo Poland provided us the awesome opportunity to have devices which we otherwise would only dream of. The second key player was the Instro, which is the distributor of Mitutoyo equipment in Latvia. So they had this idea, and they've heard that Mitutoyo Poland has done a similar laboratories in different Polish universities. And so they started to push this idea that we also need one in Latvia. And of course, the third player is Riga Technical University, because we are the ones who have the space, and we have the people who work with these machines. And why it is so great? Because first of all, as a university, we are responsible of theoretical and practical training of the students. Before this laboratory was opened, we only dreamed of having such a technical possibilities. We mostly stayed either to theoretical part when we just show the modern equipment on the whiteboard or in videos, instead of using our own, because our own equipment was a bit outdated, and it certainly didn't have any possibilities to be in such a good level as it is now. But thanks to Mitutoyo Poland, we now have the latest and greatest equipment there is for the dimension metrology, and our students are really happy to work with it and to see it in action. Not in the videos, but really touch them and work with them themselves. Besides that, we also do equipment demonstration for the industry, and it is also very important because for manufacturers to invest plenty of money for the machines which they haven't tested out, it's quite a risk. So that's why we come in very handy. We consultate them. We show them machines, we allow them to test them. So in the end, they're sure that the exact machine which they're looking for is the one which suits their purpose the best. We also do a training in dimension metrology for the industry, because it doesn't necessarily mean that you bought expensive and good equipment that you know how to use it properly. So this is our task, to prepare these people and to do them yet again consultations, or to, let's say, provide an additional so basically, yeah, we help out the industry people to use the machines properly. And we also provide the already mentioned demo measurements. So basically, if the company is not sure which equipment to buy, we are the ones who will try to help them out to understand what are their needs, what are their future plans, and thus they can create a legitimate invoice for the company. So here are some small, let's say, screenshots for some of the equipment we have here. We have additional small tools, but they are relatively boring compared to these machines. And we have height gauges, vision systems, laser scanning micrometers, micro wicker hardness testers, roughness measurement machines, round tests, contracers, and most importantly are the coordinate measurement machines, because nowadays it's basically impossible for the legitimate manufacturers to produce their parts without having them tested on the coordinate measurement machines. And luckily, thanks to Mitutoyo Poland, we have both of them, the manual and the CNC version. So yet again, the students and the manufacturers have the possibility to test them out to be sure that that's exactly what they need. And basically, we are open for 2 years, and the list of customers and people who have used our consultation is quite large. And here you can see some of them, from which the most famous, I would say, are the Latvian Plywood, Latvian Balsa, and then companies like that. But actually, a lot of, let's say, companies which roots are outside Latvia also are happy to use and to see this laboratory in action, like the Dinex, which is like a Denmark-based company, or SMC Automation, which is a Japanese company. They all are really stoked for the possibility that this laboratory is opened. And I think it's only just the beginning of a really, really long-term great collaboration between the industry and the university. So that's quickly from my side. And now I will let Jakub to give some of his experience and words about this.
Thank you, Jānis. Welcome everybody again. What I would like to stress out is that for us as Mitutoyo, as let's say worldwide leader on metrology, the most important thing is education and helping the new generations to grow and to learn what the proper metrology is. Some of us still remember the former times when we didn't have the possibility, like Jānis said, to have a good equipment at our universities and to have a possibility to learn with the newest possible technology. This is the thing that we are doing in all the countries that we are responsible for. So for Poland, Ukraine, Lithuania, and Latvia. And this is something that we would like to strongly continue in the coming years, because first of all, are the students, because those will be your future employees. Those will be people who you will be employing in the future to handle your production, to handle your quality, to handle to help you grow and build up your companies. And as much as I like it, also, you know, the current business that is going on with the laboratory, like Jānis said, whatever measuring needs you have, we have part of our equipment in Latvia already. We are planning to expand it and bring even the machines that has been brought to the market within this year to bring them to Latvia next year, so that you guys really have the cutting edge on that one. But regardless, if your company, if your, I don't know, your doctorate or whatever your domain is, if you need any kind of measurement or consultations on the metrology, we are open, and this does not limit you only to the devices that you've seen in Jānis' presentation. The whole Mitutoyo network is available, meaning whatever you need, it can be measured. And if it can be measured, then most probably, we have somewhere in the world a device that we already produced for someone that is already we will be able to measure that. As long as it's length and angle, we are good with that. So the whole Mitutoyo network is basically available for you with this plugin in Riga Technical University, and there is no limit that to what kind to this partnership. So I would like also to mention one person that is no longer with us, late Professor Ruginis, who was really the guy who from the university, and really helped us a lot to establish this this laboratory, and really this wouldn't have happened if it wasn't for him. That's for sure. Jānis right now is also, we are trying to educate him and his peers in order to make sure that we provide not only the equipment, but also all the knowledge that we have in order for you to be successful in working with us. So thank you again for to all of you for the confidence. Thanks again, Jānis, on your hands, to the university for helping us out with that. Thank you for inviting me. Thank you for having me here. And I really do hope to see you in person in Latvia soon after all this madness is finished. Thank you.
Gentlemen, thank you very much for your pitch. It was lovely to have you. Thank you very much, Mr. Lungevičs and Mr. Ruszkowski. Thank you. Thank you. We'll proceed with our next pitch. Time to get to know new OKUMA machining center, the first such a kind of machine in the Baltics. Let's welcome member of the management board at AB Metal, Mr. Arnis Balodis, to tell us more about this machine. Welcome.
Hello, can you hear me?
Yes, loud and clear.
Okay, that's good. So I'm representing a company AB Metal. It's a small family-owned company. It's placed in Liepāja. It's port city in the west coast of the Latvia. We are a small company, 20 employees, 15 CNC machines we have. We are mainly specialized in the production of the components for the different kind of industries. So we are specialized in sheet metal processing. It involves laser cutting. We have 3 machines up to 2.5 times 6 meters sizes, and tubes up to 315 millimeters. Also, we have water jet cutting. We have CNC sheet bending, 2 machines up to 4 meter length. Then CNC tube bending and CNC roll bending. Then the next division what we have, we are dealing with the machining. In the CNC machining, we have in total 7 Japanese OKUMA machines. So 4 we have in CNC turning. It's including multifunctional turning with Y and D axis, and also the simple turning, which involves just 2 axes. And the length is up to 2 meter length. And then we have also CNC milling. 3 machines up to 7 meters. Okay, now video is starting. And this is, in the video you can see our latest investment. It's a large size OKUMA milling machine, which we installed just in the March this year. So this machine represents the possibilities to do large-scale machining. It's up to 6.7 meters in the length, 3.7 meters in the wide, and 2.2 meters in the height. And it is installed with 3 cutting heads. Here you can see in the video it's a 5-axis cutting head. We also have it. And then there is 3-axis cutting head and the 90-degree cutting head. So you can do different kind of machining of the large components, welded structures, or any other steel structures. And it can be machined from all sizes of the component. So in the end, you can get very precise and high quality large components for different kind of industries. It can be agriculture industry, it can be mechanical engineering and machinery industry, it can be forest industry, or any other industries where it's needed such large machines. And if someone is needed such kind of processes, so we are very welcome to help and to other companies to solve their problems with such good Japanese machine tool. So that's in the short words, it's all. So if you have any questions, so you can please are free to email me or contact me, and we can see how we can solve your projects together. That's all. Thank you.
Thank you, Mr. Balodis. Thank you very much. It was great to see your presentation. Thank you. We'll continue. Joining us live from the headquarters of Baltic3D.eu, we welcome member of the management board of Baltic3D.eu, Mr. Jānis Jātnieks. Welcome.
Hello, everyone.
Hello.
Thank you for having me. It's my great pleasure to tell you more about my company today, and I think it would be suiting to start with a small tour. As you can see, we're in our newest premises. We have just moved to a new facility. We've managed to establish one of the largest 3D printing centers in Northern Europe. We have large machines that cover FDM technology and allow us to print different components for manufacturing companies. I'll show you what it looks like inside. There's some parts in here. And this is something that we actually produce daily on our machines. So what is Baltic 3D? Baltic 3D is one of the largest industrial 3D printing centers in Northern Europe. And actually with the installation of our newest machines, we're also one of the largest globally with this specific manufacturing equipment. Now, let me share my presentation and move on with telling you more about our company. So first of all, we have more than 22 partners around Europe that help us with 3D printing tasks, starting from helping with exactly the same technology, with larger prints or with larger orders, but also with metal 3D printing and other technologies that we don't have here in the facility in Riga. We have ourselves more than 15 industrial 3D printers available. We are very much focused on manufacturing components, spare parts to the manufacturing industry, but also to aerospace industry, which has been our focus for the last 3 years. What we do is we offer additive manufacturing services. We do 3D modeling. We also do serial manufacturing or planned manufacturing for our clients. And finally, we have established a very nice training and consultation program for our clients to quicker introduce additive manufacturing to their operation. So how can we help these companies? And then some of the applications in metalworking that we're working on is helping sandcasting companies to do production of match plates and split patterns. It's usually best suited for low to mid volume production and prototyping. We also help companies that do investment casting. We produce replacements for traditional patterns. We have very short project lead times, us being able to produce these patterns in matter of hours, actually not even weeks. And then most likely it's a good application for companies who need fine but not delicate features, because this is not a very traditional way of doing investment casting. And finally, as I mentioned also, is production parts. We are able to effectively replace aluminum and stainless steel parts and components, many times bringing more functionality to those components and creating them lightweight. Our biggest customers in this field are obviously also mentioned already, the aerospace industry. We have big pharma companies producing components for pharma manufacturing that are also buying for us, and effectively replacing steel components with 3D printed ones. Our client base, a bit more about exact lines. So we are working with Lufthansa Technik, where we produce end-use parts for the custom projects. We work with the largest, one of the largest aircraft maintenance centers in Estonia, Magnetic MRO. for fast turnaround for missing components and then retrofitting those components to actual aircraft. We have worked with SAS to supply them parts that allow them to adhere to this FAA and EASA regulation. And there's a local partner in Riga, Scandikas, that's buying iron casting prototypes from us and sand casting mold inserts and components. So our approach when thinking about how additive manufacturing can help in your business is we always look at the total volume, delivery time, and then the part geometry, and analyze those to understand whether additive manufacturing would be a good suitable technology for you. The best way to describe this is that additive manufacturing can be very competitive with traditional manufacturing technologies when we talk about components in between a couple hundred to a couple thousand components. We do economic calculations in comparison to status quo to show our clients what is the best solution for them. We always work on designs that bring in the design complexity, increase functionality, and play on the material properties, because we have some very good, nice materials that can effectively replace even aluminium parts in some scenarios. We always do specific design for our technology. So it's number one, we're able to prototype on industrial machines and then use materials. We don't need to use any substitutes for that. We actually try and design for specific material properties. If you need a higher temperature resistance or a higher flexural strength, then we can work with that. And we help you also understand how to include additive in your operation by establishing a partnership with our network. We help you to lock down on those designs and preserve your engineering intellectual property. And obviously, we also do effective advanced manufacturing training. The facility that you see here today is partially supported by the Latvian government funds. We have state-of-the-art infrastructure that we have managed to attract funding to. We have a new scientific team that's working on data-driven research and development, and altogether we're investing more than 4.1 million euros in the sector of additive manufacturing, and more specifically in airspace. That's going to be done over the next 2 years. So that was in short what we do. As mentioned, we're happy to engage with any company that does manufacturing. We're very happy to help them to understand what are their prototyping needs, how can we, improve their supply chains, and especially in this time when supply chains are not very effective in many industries, we're happy to engage and shorten them for you here in Latvia and also in Europe. Thank you.
Thank you, Mr. Jātnieks. It was really a pleasure to listen to your pitch and learn more about your company. Thank you. Thank you very much. Now, let's welcome Head of Laboratory at Institute of Solid State Physics, Materize, Dr.phys.Krišjānis Šmits, to tell us more about the metal and their coatings, development and characterization. We welcome you here on stage. Greetings.
Chairman. Yes, the topic is metals and coatings, but our institute is one of the largest centers in Latvia. I will try fast and give you some short intro about our institute. And let's see, our institute is 40 years already working in different directions, like materials for electronics and photonics, thin coatings, thin films and coatings, nanomaterials and ceramics. And we also have a theoretical group who works mostly on computational things for materials. And also quite interesting topic is materials for energy and energy storage. Our institute is located in Latvia, of course, and we have around 100 PhD doctors and 200 employees. That is the biggest material research center in Latvia. It is part of university. But quite recently, we made one new platform, Materize, which are starting point to work with industry. That is a platform to work with industry, and that is to ease the contact between industry and scientists, because scientists usually are quite speaking quite differently like industry. So Materize is a point where you can start to discuss this science. What I am doing, I mostly do electron microscopy, and I am leading laboratory in which we are characterizing different materials. And for example, this industry is quite interesting, metals and coatings, and then we can do for metals machining, polish them, cutting them, etching them. Then we can do structural analysis to see what kind of structures they are from. Then we can look at, say, chemical composition, what kind of materials are inside, and also make some heat treatment. That is how the polishing is done. Then you can see the defects, or you can see different kind of grain structures, and also some etching is done on these materials. So what I'm mostly doing electron microscopy, and these are the quite powerful tools. One of them is best in the Baltic state region, scanning electron microscope, and then we have also optical microscope, IFMs, and transmission electron microscopes. And they are quite useful for different investigation of high resolution of materials or structures. So here is, for example, is different approaches to investigate some metals with different methods. So as I said, I do microscopy, so I will go more in electron microscopy. In electron microscopy in the past was mostly for surface analysis, morphology. But recently, we are also starting to do three-dimensional investigations of materials inside the material. Not only the surface, we can etch the surface with ions, we can cut inside some trench, or we can make some lamellas. So that is, so we can go deeper in the materials to see not only the surface, but also investigate whole materials. For example, in this lamella, which is good, you can see the grain structure of metals in different depths. So, as I said, we can analyze also chemical composition, and chemical composition is good for not only from the surface, but also in the volume. So you can see the different element contents in the coatings or in metals. And we can also do three-dimensional imaging of materials and their chemical and structural composition. Here you see how the different elements are highlighted and made, and even see some unseen structures which are not possible to see from just flat analysis of surface. As I said, also we do structural analysis, what kind of structure the metals or materials are, or ceramics are. And that also we can do inside electron microscope. Here is one example how the three-dimensional things can be used. For example, this is one of the samples for our partners. From surface, we see some bubbles, and then we can see where the bubbles appears in the technological process. Then, besides all this element analysis, we can do also different kind of thermal treatment, or treatment in different atmospheres or gases, or also some chemical treatment. That can be useful to see different changes in materials in different environments. Okay, that was very short intro in what I am doing, but it's not this very big one. So if you have some interest in some material research, you can contact Einar Knox or Olga Bogdanova, which are working in Materize, to discuss more in details about some possible investigations. I just show you some partners which we are working with. It's mostly optical properties, but also some electrical and film industries. And then in the end, I can show you some short video about our clean rooms and in some infrastructure equipment what we bought. Recently, in the last 2 years, we got very big European funding to buy the best tools for material characterization. So we have large possibilities to do different kind of solid-state material research. Thank you.
Thank you, Dr.phys.Krišjānis Šmits. Thank you very much.
There is a video going down. Short.
Do you want to end it or?
I am. Sure.
Yes?
Thank you.
Thank you very much. Valuable manufacturer contact database. Wouldn't that be one awesome thing? Manufacturing connections that matter. Let's learn about it more. We welcome regional representative at Qimtek, Mr. Sigitas Brazinskas. Welcome.
Thank you. Can you hear me?
Yes, loud and clear. Thank you.
Thank you so much for inviting me. Kimtec is, let me share the first slide. Kimtec is a Swedish group. Basically, we are on the internet business and having 4 different products, which unite and make like a constellation and synergy for the entire engineering and the construction industry. We have Qimtek as such. This is a platform or marketplace, whatever we call that, network, database to match engineering operations. We have Qimtek products that is connected to higher value products as machinery, components. Big Basin is primarily for construction industry, and also is Svensk Verkstad, Swedish workshop, is a powerful 100-year tradition having engineering media. We have, I would say, 2 primary advantages that we are a regional internet business. We unite suppliers and buyers around the Baltic Sea. So it means Poland, Baltic states, Sweden, Norway, Denmark, to some extent Finland. And secondly, we are on a highly specialized sectorial approach, that is industrial engineering and construction. But let's see a little bit beyond what is ongoing now on manufacturing connections and what we have and how can we benefit from that. Krišjānis was just talking before me, and already he made a soft introduction on the platform, how science is united with manufacturing. This age is honestly network and platform. We buy through Bolt, whatever other platforms, food, which is delivered. My 2 sons, 20 and 22, they are Z generation. They just communicate through various platforms. We just heard about Industry 4.0 today, and please do not neglect the new generation definitely changes traditional relations which are still now on the market. Scandinavia is quite desirable market or region for engineering industries in the Baltics. We have to have a bridge between, but also please bear in mind, Sweden, Denmark, Norway, Finland, they're very highly competitive in terms of digital connectivity. We are behind in the Baltics, 20 places behind. So let's speak the language and get connected how our target customers want. So it means we have to know where our customer is, how they speak, how they communicate, what they desire, and that makes much more easier to do business with. I would like to point out 2 surveys which were done this year. They reflect more the first wave of Corona. So the first one done by the Swedish Export Credit Agency, with some figures on that, but it means that the Corona changed the attitude between suppliers and buyers, and many of Swedish companies have suppliers in Far East. Sweden and Denmark and Norway and Finland, they're highly integrated worldwide, but those changes do not make such a huge impact on purchasing behavior. Just around 5–10% of companies are going to replace their suppliers. So it means for Baltic suppliers and manufacturers, it's still very huge potential to maintain and sustain relations, having, of course, manifold opportunities. Kimtec also makes every year Swedish buyer barometer, simply asking buyers how they see the business going online. What is a little bit disappointing that 25% of buyers, when they upload a request for quotation, they simply do not receive any offer. So it means 25% is quite huge percentage. And also suppliers delay on submitting their offers right on time, also close to 25%. So nearshoring and the regional approach also gain importance. Now, what lessons learned and conclusions could be drawn? Only success when a company combines offline and on-site measures. So this is a key success factor. Those platforms or networks or marketplaces, whatever we call, a broad definition, gives an opportunity to match buyers and suppliers online. And that, of course, could be further used by offline opportunities. It's the same like in a trade exhibition. You have to make homework, you can maintain very professional information, communication, and that is just synergy with your traditional opportunities. So let's just answer yourself, how many of you have a corporate LinkedIn account, how active you are there, and how much do you and how deeply do you connect that to digital networks? So it means our experience shows that there's still very huge potential for suppliers to get connected through various platforms, networks. Again, I mentioned there's many definitions on that. So definitely not everyone can be successfully equal on media or on the internet business, but we have lucky cases that a company which became a member on our platform already successfully commercialized requests within a month. That's a brilliant achievement. So disruption comes. It's not only on products, services, it's also on behavior. And this is just the question of when, not if. So our advice is be ready for digital transformation. It covers not only industrial process, but also communication, marketing, business language, attitude. So that's a huge opportunities open up, not only due to Corona, but it's a time to have more and more digital applications in your business. Thank you so much for your attention, and there are my contacts. I know also quite many of regional companies, so we'll keep maintaining any contact further. Thank you.
Thank you very much, Mr. Brazinskas. Thank you for your presentation. We continue with a pitch from the head of the BVMW Nordbaden Rhein-Neckar, Mr. Josef Stumpf, speaking on the topic, small to medium-sized businesses as the motors of innovation in Germany. We welcome Mr. Stumpf. Welcome.
Hello.
Hello.
Greetings from Heidelberg, the nicest city of the world. And with me together is my colleague Reinhold von Ungern-Sternberg. I want to speak...
Hello, everybody.
Hello, he speaks from Berlin, from our headquarters. Small to medium-sized business as a motor of innovation in Germany. We have prepared some charts for you. I will tell you something about small and medium-sized business enterprises and about us, about the BVMW. You have to note that over 99% of all enterprises in Germany are small or medium-sized. That's in total over 3 million. What does it mean, small and medium businesses? They are less than 250 employees. They are family-owned or owner-managed, or they have less than 50 million in sales. A very important thing is also they provide most apprenticeships and provide education for young students. That is very special in Germany, the duale Ausbildung and that's gives a very strength to the German Mittelstand. And they make Germany one of the top export countries in the world. German Mittelstand is the innovation part in Germany. Over 60,000 patents claimed every year. Here, for example, last year. So Germany is just behind the USA when it comes to innovation. But there is a big difference in innovation. In USA, innovation comes mainly from the giant companies, from the big companies. But in Germany, innovation comes mainly from small to medium-sized companies. A lot of small to medium-sized companies are working in innovation for the big enterprises. BVMW, where we are, who we are the German Association for Small and Medium-Sized Business. We represent the interests of over 20,000 enterprises. More than 2,000 events, conferences and seminars, more than 800,000 business contacts every year. So it's a really good network. And we are over 300 representatives in Germany, which are representatives and partners for our enterprises. And for you, very important, we have over 60 external offices in almost for almost 100 countries. And I'm very happy that Reinhold von Ungarn-Sternberg is today with us. He is from our headquarters in Berlin, from the Foreign Office, and our specialist for the Balticum, and he can tell us more about his work.
Thank you, dear colleagues. Thank you, Mr. Stumpf. Well, this is where I come in. I'm here responsible for 30 countries, among them the Baltic states. I'm very happy to have this responsibility. My grandparents were born and grew up in Riga. Well, my colleague already said some words about worldwide reach of our foreign offices. What we do is we bring companies together. We organize business delegations in normal times. Now we do it online. We organize e-meetings like we did this year with several foreign governments, for instance, or with partner business associations and their members. So we, in the beginning of the year, we had the chance to organize a meeting for more than 60 representatives of 60 countries here in Berlin at our annual event with the ambassadors, with businessmen, where they could meet with our 3,500 members who attended our annual event. Now we think about a hybrid meeting for next year, where we would like to invite everyone who is interested. It will be on the 1st of March. So we can get in touch, we can talk about this idea, and we will have a perfect technical solution for that. So we can offer this as well for you. Well, we have meetings from states presidents. We have had the last years, and even this autumn, the president of Croatia, in the beginning of the year, the president of Senegal, in 2018, the president of Estonia was our guest, but we also do B2B meetings and without politicians, of course. Well, thank you.
So you can contact us. You have here our dates, and don't hesitate to write a mail. and or phone us. Thank you very much.
Thank you, gentlemen. Thank you. Thank you for your introduction. It was really great to learn more about your company. Thank you. Thank you very much. And finally, we welcome Mr. Lasse Behrmann from Lightweight Technologies Bossard to present us the pitch on multi-material-welding joining technology platform for lightweight and multi-material constructions. Mr. Behrmann, welcome.
Thank you very much, and also thank you for the warm welcome. I say hello to everyone from Vienna. I will now talk about our brand new and innovative technology, multi-material-welding, with it, as already has been said, joining technology platform for lightweight and multi-material constructions. Starting off with the team, so we have on the one side MultiMaterial-Welding, which is a small startup company from Switzerland, founded in year 2016, and together with an engineer team of around 13 engineers, they are developing and are responsible for this joining technology platform and the development and the further development of this joining technology platform. On the other hand, we have Bossard, and as a leading international supplier of product solutions, and we as Bossard taking care of the business development and working as a global distribution partner for multi-material-welding and for this technology on a global scale. So what is multi-material-welding? Actually, multi-material-welding is a fastening solution that uses ultrasonic energy, so basically a vibration, to partially melt a thermoplastic fastening element in a porous structure to create a form lock connection. So I want to show you how this actually works with the example from a sandwich panel with a PU foam and glass fiber surface, which is a common material for load floors in the trunk of a car. At first place, you see the substrate, which is a honeycomb with a PU foam, and we have our fastening element. So we set all the parameters, and after that, we initiate the process. Touching now the substrate with the fastening element, in the first stage, we pierce through the top layer, so there's no need for any pre-drilling in the substrate. And we push against the substrate and piercing through the top layer. Afterwards, the melting is initiated, and the molten material of the outer shelf of the pin, that's how we call the fastening element, flows into this porous structure and quickly solidify again. So we have a form lock connection in a fraction of a second. For this technology platform, we have two segments. On the one hand, the lightweight segment, where we have a thermoplastic fastening element melting into a porous structure. And on the other hand, we have inverse segment, where we create our porous structure using our fastening element. So the substrate material basically melts into our fastening elements. Today, I want to focus more on the lightweight segment, and I want to show you two examples out of this segment. First place, we have the lightweight pin working in honeycomb structures, lightweight loaders for thermoformed fibrous parts. We have the double pin for threaded inserts, for example, for non-foamed honeycomb parts. And we have the lightweight ZEP, which is an adaptive solution for EPP or similar foams. For the inverse, we have two technology, the inverse fastener and the inverse disc. But as I said, I want to focus today on the lightweight segment, and especially on the lightweight pin and lightweight ZEP. This is what I'm going to show you right now. Starting off with the lightweight pin. This is was invented for, as I already said, load floors or parcel shelves, but every part where you can have this kind of structure, the honeycomb structure with PU foam and any kind of composite surfaces. So we, as I said, we do not need any pre-drilling to attach, for example, this bracket, and we have a very fast process time and installation time of under 1 second usually. We use common ultrasonic processing machines, so there is no need for for any special machinery. We just adapt the software and use standard horns for this very strong and fast fastening element. And this is a video on the lower right corner here. You can see we have no pre-drilling and we just pierce through the top layer. And within 1 second, the process is done. And we have a strong connection with immediate handling strength. With a 10mm diameter pin, we can achieve more or less 1 kilonewton in axial pullout, which is sufficient for the most common requirements of all the OEMs. Going one step even further is our, as we call it, functionally integrated parts. Imagine you have this thermoplastic fastening element and also a thermoplastic hinge or functional element, can be anything. Why not just combine those two? And we are able, because we are not related to geometrical symmetric geometries, rotational symmetric geometries, sorry for that, because the movement is only in Z direction, so in this direction here. And this is why we can just add these geometries to the functional parts and attach these parts in one process step to the substrate. Here's a prototype to visualize this, this technology. We have 3 geometries printed on a 3D printed part, and in one process step, we attach this to the substrate. So there's not only the cost saving potential for our customers on the process side, but also on the part side and on the functional part itself, because you can even achieve higher strength with this type of connection. You have better visual appearance because you have no additional fastening elements and you can't even see the fastening elements. The second technology I want to show you is the lightweight ZEP. This is an adapter solution for, as I said, EPP foams or similar for screwing, for example, the self-tapping screw. The process time is the same. We have under 1 second process times without any pre-operation. And this adapter can be integrated fully into the substrate. And we have a very strong connection as well. So you can see how this adapter is mounted into the small piece of EPP. This is in this sample, it's a 60 gram per liter foam. And as you see, the process is just as quick. And it, in terms of requirements or performance of this fastening element, we can roughly say that we can achieve around 10 times of the density of the EPP foam in axial pullout, which means looking at the 60 gram per liter foam, we achieve more or less 600 newtons in axial pullout. And this is due to this deep penetration of the adapter into the substrate. And we can only be as strong as the substrate itself. And because of these anti-turning geometries, these T's, we have also very good torque load ability in this connection. And we can also have the possibility of a metric thread in this adapter for reassembly and disassembly and assembly of any parts. And again, as well, here as well, we can think of a function integrated part, just a different shape for the different substrate, but just attaching these geometries to the functional part and welding this part. You can see in the lower right corner is a video again with one process step to the EPP. So you can have less material, less parts to handle. We have no fastening element and way better aesthetics in the part itself. The business model looks as follows. So we have MultiMaterial-Welding, who's fully responsible for the software and product solution development, and together with selected partners for the ultrasonic equipment and also the automation equipment. We as KVD and Bossard on a global scale, we are responsible for delivering this integrated solution, which means the fastening element, the production system, and also quality control and life cycle services to our customers. And just one more thing to add, pretty new news from yesterday. MultiMaterial-Welding, our Bossard invested 40% of share into MultiMaterial-Welding, and we are happy to announce this and bringing now this whole technology to the global market. So thank you, everyone. And if there are any questions, I'm really happy to answer all of those. Thank you very much.
Thank you, Mr. Behrmann. Thank you very much.